Hey class, it's Professor Rourke again. So I've had a lot of questions about this particular situation in chapter 9. I know in 9.1, 9.2, it's tricky for a lot of reasons, but um, the big thing about 9.2 that's difficult is that all of a sudden they switch over to a T distribution, which we really haven't seen anything of. They tell us it's really close to the Z distribution curve, like the normal curve, but a little different. And so pretty much everything in 9.2, if you're being asked to take a sample of data and then calculate the like a confidence interval for the population mean, we in our class will always use t-stats. Some other classes might go into whether you might have to choose to use like a z-stat or a t-stat, basing it off of like the normal curve or the t-distribution, but we are always using t-distribution. So if there is anything in chapters 9, 10, and 11 where you're given a sample mean and you're used to make some sort of prediction, that inferential statistics word that we talked about a lot in the beginning of the course, we're always using t-stats. Okay, so if you want to take a look at this problem here, this is question number 16 on the 9.2 homework right now. And I also just noticed looking at this, it's pulled from a different textbook, which sometimes can mean that like it looks a little different, and that can be challenging. So let's look at this problem. It says refer to the accompanying set of data and construct a 95% confidence interval estimate, of the mean pulse of adult females. Then do the same for adult males, then compare the results. And it says click the icon to view the pulse rate for adult females and males. So this is actually, I get why this is a tricky question because we haven't really seen a lot of this, one column, like one set of data for males and one set of data for females, right? Like we've only really ever seen like we're talking about like one group. And so they're kind of trying to start this idea of hypothesis testing that's going to come in chapters 10 and then again in 11. But it's not really there yet, so it's a little tricky. Okay, so the first thing I would do is I would click the icon, and then whenever there's a blue square, I like to click that. So I've also had some students ask, like, I'm comfortable with my graphing calculator. Is it okay if I use my graphing calculator for these? And you're more than welcome to, right? The graphing calculator is great. That's actually what I used when I was a student. But the only problem is, that you probably know, is this is really annoying to type in all of these pieces of these numbers into your graphing calculator, into your table. Chances are, like, I don't know if you're like me, but I would often maybe miss up a keystroke and like maybe miss one number, and anything that's like more than 10 pieces of data, I'm like, I'm out. I just need to use StatCrunch. So when they give you the summarized data, like the sample mean and the sample standard deviation, it's really not much of a difference whether or not you use StatCrunch or use your graphing calculator. But especially if there's a set of like raw data like we have here, I highly recommend just using StatCrunch so that you can click the blue square to copy the data over. You know that it's copied over directly, so you don't have to just save so much time versus, oh Lord, typing in, let's see, 40 for the males and 40 for the females, like 80 pieces of data. No, thank you. Okay. So now that we have this in StatCrunch, is again how I would recommend you do this. It is asking us to create a confidence interval for the mean for adult females. So that could also just be a little tricky because like you'd think maybe they would start with the left column, which is males, but no, they actually want you to start with the right column, which is females. And let's just go ahead and walk through the StatCrunch steps for this. So for 9.1, if you remember, we would do stat and then we would select proportion stats because in 9.1, they were always talking about proportions, right? There was maybe like, I don't know, 50 people out of 70 have a pet, something like that. But that's not what we have here, right? We have talking about the mean. So whenever it's means, we're always going to use t-stats. And then again, in other classes, you could possibly, like if you take future stats classes, there's a little bit of a conversation of whether you should use t-stats or z-stats, but our class just tries to keep it simple, and we're just always going to use t-stats. Okay. Something also that could be confusing is we see here one sample and two sample. So you could think, oh, I have two samples. I probably should click two samples. But actually, no. That is, again, why I feel like I could see why this one would be confusing. Two samples is what we're going to use later on in chapter 11 when we're comparing two sets of data. Similarly, but a little bit different. It's going to be a different process where they essentially like subtract the two of them together. We're going to get all of this language in chapter 10 about hypothesis testing under our belts before we come back and do a two sample. Okay, so again, I feel like that could be confusing, but because we do have two samples, but for right now, we're only focusing on one sample. We're focusing on this first question is asking you to make the confidence interval for females. Okay, so we're going to do T-stats, one sample. And then this is, again, the main benefit, I think, of StatCrunch. This is like the gold stars that StatCrunch gets is because we can just select with data, which is great. Okay. You don't have to worry about finding the sample mean or the sample standard deviation. Like we could, it wouldn't be that hard, right? We could just click summary stats columns like we did before, but we don't have to. Okay, so again, we did stats, T-stats, one sample with data. And then, could be a little tricky, but they first want it for females. So we'll do that. Okay, we'll select females, and then we're going to select here confidence interval. Just in a few days, we're going to be worrying about chapter 10, which is all about hypothesis testing. But for now, we have to select confidence interval, and we make sure that it says 95%, which it does. It's at 0.95. If it was a different confidence interval, we could just change that, right? So if it was like 90%, I would put in 0.9. Okay, and the steps on your graphing calculator are pretty similar, but again, it would just be really annoying to type all those data points in and time consuming. I think this is definitely like the faster way to go, and more efficient, less likely to make mistakes, right? Okay, so here we go. We got females, the sample mean was 75.8. They tell us what the standard error is. They talk about degrees of freedom, which honestly, our textbook, this briefly drops on us, but we don't really have to worry about degrees of freedom. Again, if you took more stats classes, that is something that you'd probably maybe talk more about, but we don't have to really worry ourselves with it too much, just to understand that the degrees of freedom is always whatever the sample size is minus 1. So since the sample size here is 40, it's 40 minus 1 is 39. Okay, so here we go. So the lower limit, we have 71.393909, and it says round to one decimal place. So I'm just going to go ahead and say 71.4. And then the upper limit, it says 80.206, and says again one decimal. So I'm just going to put 80.2. Okay, so again, I feel like I understand the problem for this for a number of reasons. A, it's a lot with the T-stats. It's also raw data, so there's lots of pieces of numbers, not lots of numbers. If you're trying your calculator, it'd probably be like, oh gosh, this is terrible. Also, you would think maybe two samples because there are literally two samples, but no, we're only really focusing on one at a time, right? So we're doing females, and then next we're going to do this for males, and also making sure we do this in the correct order. Could be tricky. Okay, so now it says construct a 95% confidence interval for the mean pulse rate for adult males. So my favorite button on StatCrunch, in addition to being able to copy the data over with the blue square, is once I've calculated something, and they ask me for maybe a part B of calculating something else, I'll first see if I can just click options in whatever the little pop-up square is, right? So the pop-up square right now has my lower limit and upper limit for the first part. And so I just click edit. I can just go here and change it real quickly, just with one click, and select males, because that's what they want us to do next, is to construct the 95% confidence interval for males. So I just clicked options edit. You could, easily click it all over again and click stats, T-stats, one sample with data, but this is, one click for 6. I'm pretty lazy by nature. Okay, so I'm gonna click males, and then again, we have confidence interval. We want 95%, so I can leave that, and I can just go ahead and click compute. And it gives me, again, the sample mean was 67. So, the sample mean was lower than for the men than for the women, but I think it's going to come down to like how much lower, is it significantly lower? This is just one sample. We're guessing about the population, right? We could have just happened to pick a sample that was lower for the men. And so we'll talk about that. in a second. So the lower limit here is 63.1. The upper limit is, ooh, I have to round that, I guess. Okay, because it's 70.998. So that would bump that all the way up to like a 71.0, right? So hopefully they tell me good job. Great. Okay. So then it says compare the results. And again, this is, I understand why this one is a little different because we don't really do this a lot in this one. It's sort of seeding the ideas of what we're going to do all the way in chapter 11, but it's like it's stuff that we could do now, but it's just a little different. Okay. So it says Part A says the confidence intervals overlap, so it appears the adult males have a higher mean pulse rate than the adult females. Okay, so this is the idea. What we're going to start doing again, more so in chapter 11, is like, yes, if we look at the data, StatCrunch told us within the pop-up there that the mean for men was like 67, and I forget what the mean for the women was, like in the 70s, 74, right? So it looked like the men did have a lower heart rate, but like, was it, And so it all comes down to the confidence interval and how it's really just saying we're 95% confident. We're not saying that the true population mean was 67. We're saying we're like 95% confident that it's somewhere between 63 and 73 and 71, right? And for women, and we're saying it's between 71.4 and 80.2. So the question comes down to if they share any possible values, right? Do they have any overlap, essentially? What did I do with the fucking pencil? So sometimes even just like looking at the numbers, it can be a little tricky. Like I have to think about like almost like a number line. Like, okay, if I had some number line here, this is just for my like, getting my bearing straight. Let's say the men were from 63.1 to 71, right? So we're saying we're 95% confident that the true, what are we talking about again? Mean pulse rate for all adult men is between these two values, right? And then, so there's still a 5% chance it's not in there. It's somewhere outside of there, we're saying, but we're 95% certain. So pretty sure that the mean pulse rate for all adult men is between these values. And then for women, we are 95% sure that the mean pulse rate is from 71.4 to 80.2. Okay, so these numbers are super close from 71 to 71.4, but technically they don't overlap, right? So if they did overlap, right? So let's say maybe the men went from 63.1 to somewhere inside of the female's range, we would say that they overlapped and that there's a chance that they could be the same, right? With that they're not significantly different. And again, I know this is a lot just to kind of take in because we haven't really done this. It's just sort of planting the seeds for where we're going to go to in chapter 11. But they don't overlap, right? The men's range that we predict is always lower. Here's the men here, right? Here we are. This is the male pulse rate, and then we have the female pulse rate, and they don't overlap. Sometimes they might later on, again, in chapter 11. If they did overlap, then we could say that maybe there's a chance that there is no significant difference, right? That maybe they are about the same, right? But that's not what we have here. We have this gap here, this like bridge between, I know it's not a big bridge, but it's a small gap, but between 71 and 70.4, they're not overlapping. Okay, so this means that since they don't overlap, it appears there is a difference, right? It looks like the females are a little bit higher in the heart rate than the males. Does that sort of make sense? So for all of these questions, you know how they are. We've suffered through these a lot. First, we're going to look to see that they do not overlap, right? So that's either B or C, is that they do not overlap. I'm sorry, B or D, and my children are fighting, so hopefully you don't hear them screaming. So sorry. But B says the confidence intervals do not overlap. So it appears that there is no difference in the mean pulse rate. Well, that's not, the second part's not right, right? They don't overlap. So this means there is a significant difference. It looks like the female heart rate is actually higher, right? So then I think this will leave us with D for this one. But again, yours could be rearranged. The confidence intervals do not overlap. So it appears that the adult females have a higher mean pulse rate than adult males. Yes, I feel okay about that one. So again, I totally get why this one was tricky, because mostly we haven't really looked at two confidence intervals and compared them together. And so it's just trying to plant the seeds for when we come back in chapter 11. So I hope this was helpful. But if there's anything else I can help with or make a video or, all those things, please let me know. We are almost there. Okay. All we have left is chapters 10 and 11. Woo! And then we are done. So keep me posted for sure. Let me know however I can help. Okay. Thanks.